Hi and welcome to another video. In this video I'll be going over my Hangman solution, which is part of the Ruby part of the Odin project. And in this project you'll be getting good practice again using object-oriented programming, but also working with files. And in this particular project you will get to load a file, which will be your dictionary, and you also get to save a file and load a file of a saved game. So some additional things being added here over your prior games. So according to the instructions, we are going to be using this file here from Google, which is a dictionary of 10,000 words, and we're going to be pulling words from that file and then playing a game of Hangman with them. And you'll also be giving the player the opportunity to save their game state as well as load their game state at the beginning if they want to. So it's just like a normal Hangman game, except for in the way I built it, I didn't have a stick figure. You didn't have to. I just had kind of a number of guesses left. And I also showed the word and how many letters were guessed correctly. So let's have a look at the replit here where my Hangman game is hosted. So I'm just rerunning the game here. So some simple instructions. Welcome to Terminal Hangman. You get 8 attempts to guess the word. Good luck. Enter 1 for a new game or 2 to load a save game. So for example, if you want to load a save game, it says these are the files that are available, and we need to enter in one of these file names to load it. So let's put in test YAML. Okay, so we had this game here that we've just loaded, and we get to carry on. So we have 6 in our life left, and we get to enter a guess in here. So I'm going to enter in P. So there is no P. And I can see my misses here already, U, O, and P. So I'm going to enter in an E, and there's no E, and so on. So that's the loaded game state, and I wanted to show you from fresh game as well. And here we are back at the beginning. I just wanted to show you what it's like playing a new game. So I'll enter 1 to play a new game. You see we get a blank canvas here, so it's a secret word awaits Godspeed. And we can see that there's 5 letters in this word. Life left 8. Enter your guess, letters A through Z, or you can type in save to save at any time as well when it's your turn. So let's start with the vowels. We have an A, we don't have an I, we have an O, we have no U, E, let's go with an S. Oh, we're getting close. You can see here if I've already tried something, it tells me that I've already tried that letter and to enter in a new valid guess. So I'm still on the same life. Yeah, I didn't think there would be a D or a B. Uh-oh. Well, we didn't guess this one. It was coral. The word was coral. So we're going to enter yes to play again. And we're going to load, or not load again, but start a brand new game. Go with some A's, some E's, and then if I want to save this game, just type save, enter a file name. So let's say YouTube. Game is saved. Okay, and then I can continue playing as well. So T, A, and if I really wanted to, I could find out what the word is at the end and then reload this game. Why don't we do that? So the word is Romania, lowercase. So we'll play again and we will load this game and we will type in R, O, M, and I, and we see the guess the game. Congrats, we win. Okay, so that's the gameplay there. You get to see, starting from fresh, how the gameplay works, the prompts, as well as how to load a game, save a game, reload the game, and cases when you lose and when you win. Okay, so let's look at the files that make this game work now. And if you see, I have the files on the left side here. So we have a main.rb, player.rb, secretword.rb, and serialize.rb. So these first 3 are actually classes that have been separated and put into their own file, and serialize is a module. So now look at the main RB, and we require certain things up front. So we require the YAML module in Ruby because we're working with YAML files, and then we require these three files: player, secret word, and serialize. So this file holds the class game, which instantiates this class as well as the player and secret word classes, and it holds all the methods for gameplay, and it uses the serialize module as well, so it includes that in this class game. So on initialization of an instance of class game, we set these variables here. So we have word is equal to a new instance of the secret word class, player is equal to a new instance of the player class. We have a blank display, which is being used to communicate with the player how many letters are in the word and how many accurate guesses and the positions of them in that word. And then we have a life equal to 8, which counts down as you lose life. And then we run the load or new game, which asks you whether or not you're going to enter 1 to play a new game or enter 2 to load a saved game. So looking at the load or new method here, like I said, enter 1 for a new game, 2 to load a saved game. We get that input from the user, and if it is equal to 1, then we run the select word method on the word variable, which, if you recall, is equal to the secret word class. So we're running a method within the secret word class, or within that instance of secret word class, to select a new word, and then we are playing the game. Else, if they don't enter 1, then we're going to load the game, run load game method, and we're going to put the display onto the screen using join, and then we're going to play the game. So the make display method here, this is what makes the underscores based on the length of the secret word. So if you have a secret word that's 5 letters long, then we have 5 underscores at the beginning of the game. And this only runs if the display is blank, otherwise it does not run, because it's going to assume that it's a loaded game that has already made the display, so we don't need to run this method. I could probably use a guard clause here, to be honest, rather than using this conditional the way I have, stating something like that if this display is not blank, then return false, otherwise run this code. Either way, what this does is it looks at the length of the secret word. So word.choice, this is coming from the secret word class instance, and then we're going to strip any leading or trailing spaces and get the length of it, and then we're going to set the display. We're going to make a new array which is the same length as the secret word, and we're going to enter in these underscores as the value at each index. Now we could put a quick prompt on the screen, and then we join that display. Because it is an array, we want to actually turn it into a string so it doesn't have the square brackets, and then we put that onto the screen. Okay, and then each turn we're going to ask you whether or not you want to save the game, and in order to save the game we're looking for this string here exactly. So if the player has guessed or entered save, then we ask them for a file name, we get that and get rid of trailing spaces, and then we enter it as a argument into the toYAML method, which will come later. And then each turn we want to be looking for matches. Obviously we want to be seeing if the letter that you have guessed is within the secret word. So I do have a guard clause being used here, return false if the player guesses equal to save. Obviously we don't want to be running this match method on an instance when you're trying to save a game. And also I'll show you below that each guess is being validated for being a valid entry, a single letter, and not a series of letters or any numbers. So as long as that rings true, then we're going to run this block of code here. And what we're looking at here is if the secret word includes the player guess, so we're using this handy include method, then what we're going to do is create a new array, and we'll call it word array, and it's going to be the secret word. Okay, so we're making an array from the secret word, and we're running the each with index enumerable on that array of the secret word, and we're going to be looking at the letter and the index, or the value in the index. And what we're doing here is we're saying if the letter is equal to the player guess, then set the display to that index to the letter. So we're saying that if there is a T in index 0 and the player has guessed T, then on the display, which if you recall is the string of underscores, set the 0 index equal to that letter. So then that's going to give a prompt back to the player to let you know which guesses are correct and where they exist within the word to help you guess the word. And then we put some prompts again, so we just say few, that letter is in the word, and then we join the display because we're looking at an array here, so we join it again so it looks like a string on the screen without the square brackets. Else, if the word choice does not include player guess, then we're going to run the miss method, which comes next. And this is the miss method here, and I do have a guard clause in here to return false if the player guess is equal to save. However, in retrospect, that is unnecessary because this method is only getting called by this block of code here, and this block of code here is only going to run if this is not true. So I do not need the guard clause right here. Okay, and what this block of code does is it's going to add the player guess to an array within the player class called misses, if it was a miss guess. So if we just look in the player class quickly, when that's instantiated, we do have an array called @misses here. So this miss method in the game class is passing that value to that array within the player class. And then it's going to say, it's going to put a prompt on the screen telling you that that letter is not in the word, and it's going to create a string on the screen that shows you all of the values that you have guessed incorrectly. And then we're going to subtract 1 from the life variable as you lose life, and then we're going to put the display back on the screen, and that's that. So each time we're also going to check if there is a winner. So we've got to, the way we do that is we have a conditional that's looking to see if the display is equal to the secret word. And if the display is equal to the secret word, then we put congrats, you win, and we set the life to 0. Else, if the life is equal to 0, then we know that the game is over, and we say unlucky, and we show the word that was chosen. And the reason we set the life to 0 here is that it ends the game loop, but you've already won the game. Okay, and then we want to allow game replay, so we have this method replay here. So we're prompting enter yes to play again, and we get that response. And if it is equal to yes, then we're going to run the new game method. Else, we're going to say thanks for playing. And the new game method is simply just calling a new instance of the game class, which is just going to reset everything, and then calling the play game method on that instance. And here is the game loop. So in order to play the game, we need to make the display, and then we run a loop until life is 0. So this is obviously going to check each time. If life is not yet 0, then it's going to run through this loop here, and then when it is equal to 0, it's going to skip and run the replay method. So what we do here within this loop is we show how much life is left. We ask for the player input. We see if they want to save the game or not, and we look for any matches, and we check for any winners. And then once this loop has expired, we run the replay method here. And just at the base of all of this code, I just have these simple instructions: welcome to terminal Hangman, and then we instantiate a new game class instance down here. So let's take a look at the game class here, and upon initialization we have 3 variables. We have a guess, misses array, and a guess history array. So this misses array obviously contains every guess that you've made that was incorrect, and the guess history contains every guess that was made and validated and accepted. So that includes both the misses and accurate guesses that were within the secret word. So we have this player input method here, and what this is doing is it's prompting the player to enter in a value, so one letter A through Z, or they can enter in save to save the game. So we're setting this variable input equal to the input that the player makes, and if it is equal to save, then we set the instance variable guess equal to that input, or equal to save. Otherwise, we have to validate the input to make sure that it is a valid input and is not a guess that has already been made. And we do that using the next 2 methods here. So we have validate input and check history, and these methods actually work together. And if an invalid guess is made, and then if an invalid entry is made, or a guess that has already been made is made, then we have a loop that continues until a valid entry is made that has not already been made, if that makes sense. So we have this loop here using until. So until the input length is equal to 1 and it is valued from A through Z, we're going to keep prompting the user to enter in a valid guess. Okay, so once this is satisfied, so once you enter in a value that is length of 1 and between A and Z lowercase, we're going to set the instance variable guess equal to the input. Then we're going to run the check history method, passing in the input as an argument. And this check history method is what it's doing is to make sure that you haven't already given this exact letter. So it's going to look at that guess history array, and if it includes the input, then it's going to say you've already tried that one, and it's going to rerun validate input, right? So it's going to rerun this loop here until you enter in another guess. Okay, and it's going to do the same thing and pass that new guess into check history. So if the guess history doesn't include the input, then this is going to return false. I could use a guard clause here instead as well, just to make it a little cleaner. But what that will then do is this will return false right here. So your guess instance variable is equal to the input, and then it executes this last line here, which is going to add that guess to the guess history, right? So it's a valid guess that's being added. Okay, so that's all the player class is doing, is it's soliciting input and validating it. Okay, the secret word class is a little bit shorter again, and all that has here upon initialization is a single variable, and that is the choice. So that's the choice of the word from the Google dictionary list. So in order to select a word, we have a blank array that we set here, and then we open the file and we go through each word in the file, and we have a condition here. So we add the word to word array if the length is greater than or equal to 5 and less than or equal to 12. So we're setting these criteria of getting words between 5 and 12 characters long. And then we just sample this array to get a brand new word. This isn't the most efficient way to do it. It would actually be more efficient to sample the words within the file here rather than import them all into this array and then sample from that. So that would be something I would do differently next time. But that's how we get the secret word. So we're just using this file to open on this Google no swears.txt. And the serialize module here. So according to my notes here, so we have methods to get the file name, to serialize to YAML format, and to load the game from YAML. And these are all called within the game class. Okay, and first off, we want to look at load game. So what we do is we check if there is a saved game in the games folder, and if there is, we display the file names, and then we get the name and pass it to the load YAML method. Otherwise, we send the player back to the start if it doesn't exist. Okay, so what we do here when we're loading a game, so you've just started a brand new game and you enter 2 because you want to load a game, right? So that's when this gets run. So we're looking here, if the file exists, saved games, which in this case it does, then it's going to say, okay, these are your files, and we're going to look at the children within that directory. Okay, and we're joining those to create strings. And then we prompt the user to enter one of the file names in this format. We get that file name, you run the chop method on it, and then we pass that file name to the from YAML method. So what we're doing here is we're taking data from YAML and passing it into our program here to be read. Otherwise, if this file doesn't exist, if the saved games file directory does not exist, then we say there are no files to load, you have to play a new game. Okay, and then we run the load or new method. Okay, so what we're going to look at here is the toYAML method next. So my notes are saying here that we need to make a directory if it doesn't exist, and then create the file using the user's file name, and then convert to YAML and close it. So when you want to save a game, you need to convert your game state into a YAML format. And so what we do is we make a directory save games unless it already exists. So in this case, in this game on Replit, that directory already exists, so we don't need to do this. But if it was a brand new upload to Replit, it would want to execute this to make that saved games directory. And then we run file.open to create a new file based on the file name that's provided. Okay, and we use this string here to make sure it's the right file format. And we're entering as a write to this file using W here. And we run this dump method, YAML.dump. So this is pulling from the Ruby module of YAML, where we require YAML in the game main.rb, in the game class file. And we're dumping these instance variables into these as values to these keys. So YAML is essentially, it's just a hash, and we have key value pairs. So we take the variables that we need to take to conserve game state. So that is the word that's being used, the secret word, the display, the life left, the player misses, and the player gets history, right? These are all the variables that control the game state, and we just set these keys, which are hard-coded, into these instance variables, which are going to be dynamic depending on where you're at in the game, right? So that's all we're doing, is we're creating this hash of key value pairs. And once we've written these values into this hash, then we close the file and we tell the user that the game has been saved, and then the game continues from there. Otherwise, if we want to load a YAML file, then we set this variable f is equal to YAML.load, and instead of open here, we're calling the read method, right? So up here we use open to create the new file with the W, but in this case we're just reading from it. So we read the file in this directory based on the file name that's provided, and all we're doing is we're going the other way around now. So what we're doing here is we're just setting each instance variable in the class game equal to the value within the array, right? This is how we're accessing these values here. Okay, and that's it. That's pretty straightforward, I think. It took me a while to get my head wrapped around how to work with files and convert to YAML and read from YAML. But once I understood it, it was very straightforward. It's just like anything with programming, you got to get your mind around it, and then once you do, it seems so much simpler than the giant mountain standing in front of you when you're trying to solve it. Okay, that's the gameplay. This is a pretty long video. Hopefully you get some value from this and it makes sense. And now I'm starting to read 99 Bottles by Sandy Metz, and it is a book all about object-oriented programming, and I've watched a couple videos of how she approaches code, and she's not a very big fan of conditionals. I think it's give or take depending on who you talk to, but after watching videos and starting to read her book, and then looking at how I've written these files, I can see there is so much unnecessary complexity in the way these are structured, in the way I've structured these games. So that's something that's really valuable to consider, is how to make things much more simple and robust and much more easy to review. So that's something I would recommend too, is checking out some videos from like RailsConf. Sandy Metz is a really good resource, and start reading that book, because I think it will take your understanding of object-oriented programming up another notch. Anyway, please like, subscribe, leave any comments. I'd like to see what other people have done, and I'll see you on the next video. Thank you. Bye-bye.